meant to record going over the homework and I kind of forgot. So, oops. So what about this? It says a particle starts at time t equals 0 and moves at a constant velocity of 3 for 4 seconds. How far did it travel? What we could do is we could make a little graph here. If this is my t-axis, if I start at t equals 0 and I move for 4 seconds, could I make 1, 2, 3, 4? Yeah? And I picked a really easy one here to start with. If the velocity is always at 3, this is my velocity, this is my y-axis, could I say this is 3? And if my velocity is at a constant value of 3 for 4 seconds, do you agree that it would kind of look like this? Do we have a formula to find like how far to travel distance? Distance equals.
Wouldn't you just find the area of
That's where we're going, yes. Two things we can do here. One of them is we could do old-fashioned distance. Distance equals rate times time, right? Do you know that formula? You should know that formula. When I was in high school, we called this dirt. Like, oh, you gotta use dirt because it kind of looks like the word dirt. What is the rate that I'm using here? How fast am I traveling? I didn't put any units on this, but the rate would be the same as the velocity, yes? That's how fast you're going. It's like your speed. And what's my rate? And how long am I traveling? 4 seconds. So we could say, how far did I go? 12 units. Whatever units. I didn't put any units on this. I was just trying to get you to see the connection here. What you should see, what she's noticed already, maybe learned already, is this kind of matches an area formula, right? What if I came over here and I kind of drew this down and I said, well, I stopped at 4 seconds, and I started at 0 seconds. What shape does that make there? A rectangle. And do I know how to find the area of a rectangle? The area of this little velocity graph would be the length times the width, which would be 4 times 3, which would also give me an answer of 12.
will it always make a rectangle?
No.
So wouldn't the distance formula be easier? Because what if it makes a shape we don't know?
Well, what if the velocity isn't constant? Are we going to always be able to make a shape? What if my line was curved? Am I going to be able to make a shape? That's where integration comes in. We're getting to that. But we want to look at it, and some of them are going to make geometric shapes, and we're going to be able to use geometry. But the idea is, most of the time, our velocity is a function, right, that has t in it, and our velocity is not going to look so nice. And that's where we're going to have to use some calculus or some integration to do that. So, I think I want to figure out what we started here. What if, as Cassie said, what if it didn't make a rectangle? What if it looked like this? And you don't have to draw this exact picture here, but just draw something that's not a rectangle. From A to B, we'll say. The big connection here that we want to make is when you want to find how far something traveled or the total distance of something, you can relate that back to the area. If this is the velocity function, and this is how long it went at that velocity, if we could find the area, then that would be really great. So how could we find the distance here? It'd be really great if we could find the area of it. Do we know how to find the area of something like this? Have any geometric formulas that match that? No. We want to find the area. We'll get to that of how we could do that exactly. What we're going to kind of spend the next few days on is estimating the area. Could I get really close by drawing in some geometric shapes that maybe I know how to find the area of? we're going to stick with rectangles for a little bit. What if I kind of broke this up into separate rectangles? Like, what if I said, like I could draw a rectangle like here, and then I could kind of go over and draw a rectangle like this, and draw a rectangle like this, maybe like this. Oh, that's kind of really bad. If I like broke that up into a bunch of different rectangles, do you agree I'd get pretty close to the area? It wouldn't be exact, but I'd get pretty close. So how could we estimate this, the distance or the area? We could use any shape really, but we're going to kind of focus on rectangles for a while. And really, we're going to get here eventually, but this is where the idea of integration comes from. Do you agree that the smaller my rectangles are, the closer I'm going to get to the actual area? Like I made these kind of small. What if I broke each one of those up and I got a little bit closer and left out a little bit more white space on top? You agree that? Like if I used 100 rectangles, that would be a lot closer than if I just used like 4 rectangles. Who wants to make 100 rectangles? Not me. But that's the idea of where integration comes from. What we're going to focus on today is, 1, how can we use rectangles? And 2, how can we just use geometry? If it makes a geometric shape, you don't have to estimate. You can give me the exact area. So I have kind of 2 parts for you. So let's jump in here with this one. A particle starts at x equals 0 and moves along with velocity of 3t for t greater than or equal to 0. Where is the particle at time t equals 3? That's kind of like saying, what is the total distance that it traveled in that time? And we know distance equals the area if we can find it. So the first couple on your homework today are going to be really nice in that when you graph this, you should be able to make a geometric shape. So step 1 is let's graph this. This is my velocity axis. This is my time axis. I don't know. I just gonna make a few lines here. I'm only going to 3 seconds, so I'm not gonna go too far on my time axis here. And I'm just gonna graph this. The velocity function, 3t, means that would be a line intercept of 0 and a slope of 3, or you could just plug in what happens at 1, 2, and 3 seconds. But that would just be up 3 over 1. Up 3 over 1 would be I'd be up at 6. So my graph's not so great. And then I would be up at 9 at 3. Maybe. Yeah. Problem is this is not very straight here. Do you agree that that should be a straight line? 3t, right? Draw the line down where your time stops. We're stopping at 3 seconds, so I'm going to draw a line down at 3 seconds. Is that a shape that I know how to find the area of? Which means I don't have to estimate it. So look for those. If it's a geometric shape, then you can do that. On the AP test, every year there are questions that they want you to use area for. And people think, I don't know what to do. And all you got to do is break it up into area. So if I want to find where is the particle at time t equals 3, I just want to find the distance traveled from 0 to 3 seconds. And that's the same as saying the area covered from 0 to 3 seconds. So we want to start thinking about, just like with derivatives, we think derivatives equal slope. we want to start thinking about integration. Integrals kind of equal the area that's covered of that closed figure there. So my area here, how do I find the area of a triangle? 1/2 base times height. And this one, what is my base here? 3. And what is my height at 3 seconds? How tall am I up here? 9. And I'm just going to leave that as 27 halves. No need to write it as a fraction. There's some other ones on your homework. Rectangles we should be pretty good with. The other one that comes up every now and again is trapezoids. For a trapezoid, you could always break it up into a rectangle and a triangle, but I'm just going to kind of throw this formula out here for you in case you want it. Do you remember how to find the area of the trapezoid? Remember, a trapezoid has 2 sides that are parallel and 2 sides that are not parallel. Like this, we could say. You making fun of my trapezoid? There's lots of different ones. Lots of times we think of a right trapezoid would look like this. Like these sides are parallel, and then this side comes in like that. That's also a trapezoid. 2 parallel sides, 2 not parallel sides. Area of a trapezoid is 1/2 times the height, which if it's just, the side could be the height, or if it's like this, you'd have to draw the height in. Remember, the height has to be perpendicular. And then you have to add the 2 bases together, the parallel sides. So we call this like base 1 and base 2. So this would be B1 plus B2. Again, as you get to those on your homework, you can use this formula, but you could break every trapezoid up into rectangles and triangles, and you'd get the right answer. But I think this is sometimes easier to use. So you might need that for your homework. What I really want to focus on today is the ones that we can't use geometry for, because that's the part that's kind of the new part. And this is really why I printed your notes out, is just because I didn't want you to waste time writing this whole problem down. Same idea, but look at the difference in the velocity function. Now it says the particle starts at x equals 0, moves along the x-axis with velocity of 2t squared, which means that's not going to be a linear function, which means it's not going to match up to a geometry formula that we have. Same question, where is the particle at t equals 3? And notice it's telling us use 3 rectangles of equal width and heights determined by the midpoint of the interval. So let's graph this, and then we'll talk about how we can use these rectangles. So here's my velocity again. Here's my time. Again, I'm only going to 3 seconds, so don't make more than you need. I'm going to make these intervals kind of big so that we can see our rectangles. Try and be as accurate as possible. Think about how high we need to go on the y-axis. At 3 seconds, what is my velocity going to be at 3 seconds? 3 squared times 2, 18. So I need 18 on my graph. If you want to count by 2s, if you want to count by 3s, it doesn't matter, but you need to make sure that you have 18 on your graph, or at least know that that top number is 18. I think I went by 2s. I don't even think got squished together, but that's right. This is a parabola, so we should kind of know what it's going to look like here. At 0, do you agree I'm going to get 0? At 1, I'm going to be at 2. At 2, I'm going to be at 8. And at 3, we already said that we know we're going to be at 18. And And it should look something roughly like that. I'm going to draw my line down for 3 seconds. We can't just use a geometry formula right here because this is a curved line, right? And that's the idea. In calculus, we're able to deal with curved lines in a way that we've never done before in geometry class. Today, it says use 3 rectangles of equal width. So it's really nice if I'm using 3 rectangles of equal width and I have only 3 seconds here. Does it make sense that we would break that up into like, this would be 1, this would be 1, and this would be 1? You see how that could make like 3 rectangles? Haven't made the tops yet though, because I'm not to that part yet. And they say use the height of the rectangle is determined by the midpoint of the interval. So the midpoint of each one of these, so the midpoint between 0 and 1, do you agree that that would be like at a half? Sorry, my heights aren't so good here. If I drew that as the height, do you agree that that makes a really little rectangle here? Why do you think they say use the midpoint as the height? Do you see how this side, this part is not included, but over here it's kind of overestimating, so it kind of gives you a pretty good estimate. So midpoint seems like a good idea. See what happens as we get bigger. Between 1 and 2, do you agree the midpoint would be about right here at 1.5? And if I drew in that rectangle, my lines are terrible. It would look something like that. And again, I have a section that I'm not counting, but I have this extra space out here that I am counting. And then for my third rectangle, I get something like that. You with me on that? Where I got that from? 3 rectangles, so that's how I knew to make 3. And then I use the height determined by the midpoint of each one of those. And now what I want to do is I want to find the area of those rectangles, and I want to add them up. Because if I take the area of this rectangle plus the area of this rectangle plus the area of this rectangle, do you agree that's going to give me a pretty close estimate to what the area is? It's not perfect. It's not the exact area, but it's going to give me an approximate area. So now what I want to do is find the area of each rectangle. I forgot my word. And we know area of a rectangle is length times width, or width times height if you want to use it in terms of what they're doing here, but I'm just going to use length times width the way we've always done. Which part is going to be the same for every rectangle, the length or the width? The width. Do you see that? Do they all have the same width? What is the width of each one of my rectangles? 1. From 0 to 1, from 1 to 2, from 2 to 3. So I could say that the width is going to equal 1 for all of them, but it's okay, we can do each one separately. What if I had 6 rectangles on this one? What would the width of each one be? A half. Do you agree with that? Because if I had 6 rectangles, then I'd break each one of these up into another one. And so the width isn't going to always be 1. It depends on how many rectangles you have. What about the length? Maybe we should start with just the first rectangle. How would I find the length or the height of this? How would I find what that value is? The x value here is 1/2. Do you agree with that? How can I find the y value of this? Could I plug it into the equation? Is that y value where it hits that curve? On all of these, is that y value where it hits the curve at 1.5? Is this y value where it hits the curve at 2.5? The y value is coming from the curve itself. That's why it's changing. It's not going to be the same every time. So we could say that the length would be, I'm going to say, v of 1/2. So you can have that in your notes of where it's coming from. I'm just going to plug 1/2 into this function. And I could actually work it out. And get 2 times 1/2 squared. Overall, if you want to write a little formula for yourself, to find the length or the height of each rectangle, however you want to say it, you're just going to take the midpoint and plug it into the function. And so you're going to do v of that midpoint. And every time, if you're using the midpoint as your height, that's how you're going to get your values that go with that. Eventually, you don't even need a graph for this, because if you know the midpoints, you don't actually have to make the graph to do this. I want to write this total area here, so we want to do each one. I guess we could work this out. What is this? 2 times 1/4, which is just 1/2. Do you agree with that? The area of the first rectangle is 1/2. Could we figure out the area of the second rectangle? The second rectangle, area equals length times width. How am I gonna find the length of that second rectangle? First of all, what's the midpoint here? 1/2. I'm gonna write that as 3/2. How do I find the y value when x is 3/2? Plug it into the function, right? Because that's touching the function. That's how I know how tall to make my rectangle, is where it touches the function itself. You follow me on that? So I'm going to take 2 times 3/2 squared, that's my length, or my height, times the width, which in this one happens to be 1. Could I do the third rectangle? You do the third rectangle. At least make your formula, and then we'll work it out. What am I going to plug in into this one? What's that midpoint? 5/2 times 1. And really, I don't know if you've worked this all out yet or not. Our total area is just going to be adding those up. So I have 1/2 plus, what would that be? 9/4 times 2 is 9/2 on the second one. Do you agree with that? And this one would be 25/4, but then times 2 would be 25/2. And we could say an approximate area for this would be 35/2 or 17.5. Here's a little formula for you. The area of each rectangle always be the width of the interval, depending on how many rectangles they tell you to use, times whatever function you're using, and we're using velocity right now, but they might just give you f of x at some point. But you're going to take whatever that midpoint is, and you're going to plug it into that function. And so I wrote times f of the midpoint, or v of the midpoint if it's talking about velocity. This is your width. This will always be your height of the rectangle, because you're using that curve itself. So we're going to do another one of these, same problem, only I'm going to give you more rectangles, and I'm going to show you how you don't have to graph it out every time, and how you can do it all in one step, hopefully. All right, so make sure you write that down. So same as number 2, same directions, but now I want you to use 6 rectangles, but I still want you to use a midpoint. But instead of doing each one separately, let's see if we can kind of do it all at once. So 6 rectangles, I'm still going from 0 to 3. Yes? That's totally not equal, but that's okay. Could we break this up into 6 equal rectangles? What would I do to make 6 equal rectangles? Half of each one of these, right? So 1/2, what would that be? 3 halves and 5 halves. 1, 2, 3, 4, 5, 6. Notice I'm not making a big graph. I could make that big graph again. I could make that curve. But I really just need to figure out my width, and I need to figure out my length. So what would the width be on each one of these rectangles? A half. Do you agree with that? 0 to 1/2, 1/2 to 1. The width is 1/2. The length is going to be different for each one, but I'm going to use my midpoints here. Could I go through and figure out what the midpoint of each one of these are? Oh man, look at this good fraction work here. What would be the midpoint between 0 and 1/2? 1/4, 3/4, 5/4. I totally don't have any room here. I'm going to write this one above here. 7/4, 9/4, and 11/4. First of all, I want you to get that we're finding the exact same area that we found on number 2. The only difference is we're making more rectangles. What should happen is the more rectangles you make, the closer you get to the actual area. How do I find the height of each one of these? Or the length? What did I tell you? We're going to take each of these midpoints and plug it into that formula, right? So I'm going to use V since that's what we're using here. I'm going to take V of each midpoint. And we could do this in 6 different steps and then add them all up just like we did in number 2. But the idea is once you get what's happening, you can just write this all out at once and you can use your calculator to help you a little bit. I'm going to write it like this. Each rectangle. For the first rectangle, I'm going to take the width, which is 1/2, and I'm going to show you this so you can see it in your notes, times the height, which is going to be V of the midpoint, which is 1/4. So if you want to go ahead and plug it in, you can. Plus the second rectangle, I don't have to draw it to know that the width is still 1/2, and the height is going to be V of 3/4, because that's my midpoint, plus 1/2 times V of 5/4, that's the third rectangle, plus 1/2 times V of 7/4, plus 1/2 times V of 9/4, plus 1/2 times v of 11 force. That's all messy down there. And again, it's up to you on how you do this. When I do this, and they all have the same width, could I just factor out a 1/2 and then do all those computations and then multiply by 1/2 at the end instead of doing all that, all those steps? You don't have to, but I think it's a nice thing. So I'm going to take out the 1/2, and then I'm just going to go through and I'm just going to plug 1/4 into this function, and 3/4, and 5/4, and 7/4. And they're fractions, but they're not that bad to do. We're going to run out of time soon, so I'm going to kind of speed this up. But 1/4 squared would be 1/16 times 2 would be 1/8. 3/4 squared would be 9/16, but then times 2 would be 9/8. You follow me where I'm getting these numbers? We're going to square this and then multiply by 2 every time. So 25/16, and that's going to be 25/8. And then that's going to be 49/8. And then 81/8. And then, what was my last one? 121/8. If you haven't been using your graphing calculator, you really want to start doing that. One, because it's really easy to add fractions on there. You just use the division button. And remember, if you hit math 1, it'll change that back to a fraction. You really want to practice doing that. Also, you need to bring your graphing calculators tomorrow because we're using them. We're going to program them to help us speed this process up. So make sure you bring your graphing calculators. And you really need to start using them. When we have our AP test in here, our practice AP test, no scientific calculator is going to be allowed. You're only going to be allowed to use that. I just did this on my calculator, and I highly recommend you practicing this. But I got 143/4 times 1/2 was 143/8. I really want you to leave that as a fraction, but just to give you an idea of how it compares to our first one, 17.875. When we only used 3 rectangles, we got 17.5. This is a more accurate answer. We could even get more accurate with more rectangles. Your homework today is just page 270, 271, 1 through 4 all. Some of them are geometry, some of them are like what we just did.
I need to find students out. Let's please. I need Devin Haywood, Kate Beagle, Kristen Wood, Logan Vandermeyer. The office, please.
Pretty sure I forgot to put the numbers and stuff up.
I did it.
Oh, you did?
Yeah.
Okay.
Like you did it on the front.